Welcome to the Everything Building Envelope podcast. On this show, we discuss topics relating to the exterior building envelope, such as waterproofing, glazing, cladding, roofing, and more. You can subscribe to this podcast on iTunes and Stitcher. For previous episodes, show notes, and bonus video content, check out our website, everythingbuildingenvelope.com. Now, here's your host for the Everything Building Envelope podcast, Paul Beers.
Hello, everyone. Welcome to another episode of everythingbuildingenvelope.com podcast. And in this episode, we're going to talk about Irma again. I'd like to welcome back the first three-time guest, Will Smith, who we work together at GCI Consultants. Welcome again, Will.
Thanks. Great to be here, Paul.
So, Will, we're going to talk today about Irma, which, as we're recording this, was 2-3 weeks ago, and kind of what we're starting to see some of the trends are with regards to damage, I guess I would say. And kind of just a big broad brush is obviously there were some devastating winds that struck the Florida Keys and some areas in Southwest Florida. It was a big storm and it affected virtually the entire state. And the big story in the rest of the state, once you get beyond power outages and trees, landscaping, things like that, was a lot of buildings leaked water. So that's kind of, kind of my 2 cents. Are you sort of hearing the same sort of things?
Yeah, having lived through the storm myself and experienced another hurricane, I've been here for many years, so I've lived through several of them. This is not anything new, but it's always something that we learn a little bit about. In my case, located in Palm Beach County, we had hurricane winds, somewhere in the upper 90 mile per hour area, and which in itself, those of us who live in the hurricane zone don't look at that as being horrible. It's bad enough, but it's not as bad as it could be. But the fact is that they go on for so long, and you have that with heavy deluge of rain at the same time. As one person told me the other day, going through a hurricane is not so much a windstorm or a rainstorm as it is a durability test. I thought that was a pretty good insight into what we experienced during a heavy hurricane.
That really is good stuff. As you were saying, I was just thinking 90 mile an hour winds. I mean, those are high winds, but I don't think Florida gets enough credit for how well built things are down here. We have the strongest wind codes in the nation, probably the world. And a 90 mile an hour winds in some parts of the country, or certainly, offshore and internationally, would cause much, much more damage than it does in Florida. And I really think that there's a lot of credit due to the design and construction industry for doing such a good job to where it's not necessarily a catastrophe like it would be had the quality, not been as good as it is.
I think that's very true. And just so the listeners know, there was an article published. Obviously, it's still very early, and a lot of investigations are going on, and it's going to take some time to get the final results. But the early news is that the changes in the Florida Building Code were proven to work, and the extent of the damage in Florida was far less than it would have been had the same storm occurred 20 or 30 years ago, just simply because of the improvements in our code and our building methods.
That's really great. So one of the big improvements to the code obviously has resulted in what we'll call, for lack of a better term, hurricane windows. And so I would pose the question to you, what's your definition of a hurricane window as it exists in Florida these days?
Well, that's a great question. And I think if you were to ask that one question from 30 different people who manufacture windows, you'll get 30 different answers. Essentially, though, one of the things that I look for in hurricane-resistant windows are windows that have been tested and proven to Number one, resist the wind pressures that can be expected in this environment. And secondly, be able to resist damage from windborne debris, which is called the impact test. And third, have a higher level of water infiltration resistance than is normally seen in most other parts of the country.
Now, you said hurricane resistant window, so I picked up on that. There's people out there that think windows should be hurricane proof. What would your thoughts be the differences between a hurricane resistant window and the misnomer, I would call it, that there's such a thing as a hurricane proof window?
Yeah, good point. There really is no such thing as a hurricane proof window. Windows can be made to resist wind pressures, made to resist impact, made to resist water, but there's always going to be the possibility of circumstances when the wind pressure exceeds the ability of the window or the tested ability of the window. The same thing for impact, the same thing for water. We can design and manufacture products that provide a certain level of protection, but at some point in time, that level of protection can always be exceeded. So there is no such thing as hurricane proof. For example, if you have a window that has impact resistant glass, many people misunderstand that just because it's impact resistant, that doesn't mean the glass can't be broken. It can, and it will be broken if it gets hit by some big, large, heavy object. But the point is that, and the purpose of that impact resistance is to prevent that object from going through the glass and creating a big hole in the side of the building where the glass used to be. So it has resistance, but it's not hurricane proof. The same thing with water. It can resist water up to a certain level. It's not a submarine. We don't build windows so that they can go in to resist water at huge levels and volumes of water and wind pressures.
So can you talk a little bit about what the structural requirements are for windows required by the code and also by industry standards, and then how that compares with what the water resistance requirements are?
There is a difference. For example, and some people would call it a disparity in the pressures that are required for wind resistance versus pressures that are required for water resistance. For example, a typical single or even a two-story residence in Florida will probably require a capacity of, let's say, as approximately 60 pounds per square foot of pressure resistance, and that can be converted into wind speed. And in this case, let's use the 60 pounds per square foot. That's approximately 150 mile per hour wind. So the thought is, the way it's tested is that when it's in a laboratory and that window is attached to a structure in a laboratory, they blow wind on this thing, in this window, at a wind speed of about 150 miles per hour, and it's not supposed to fail. It's not supposed to come out of the building. It's not supposed to come apart. It's supposed to hold in place. Now, at the same time, when you test that very same window for resistance to water pressure, instead of using 60 pounds per square foot, the code says that you have to use a percentage of that, which works out to be approximately 9 pounds per square foot. So there's a big difference between wind at 60 pounds per square foot or 150 miles an hour and wind-driven rain at 9 pounds per square foot, which is the equivalent of approximately 59 miles per hour instead of 153.
So why can't windows be made with higher water resistance, like the structural requirements?
Well, some windows can, but they're pretty rare. And obviously they can be rather costly, and they also have a lot of limitations. For example, one way to make a window watertight and be able to resist this kind of pressure is to design a window that is completely sealed shut, where the glass and the aluminum or wood that makes the frame is all sealed together and provides a impenetrable seal to resist water from coming through. This would give you a very high resistance to water pressure, and there are a couple of manufacturers that make high-rise glass windows for high-rise buildings, like all glass buildings, curtain walls, that have very high resistance to water at those kind of pressures. But obviously the deficiency in that for the typical homeowner is you can't open the window. There's no ventilation. There's no emergency escape in the event of a fire from a bedroom, which is a requirement of the code, and so on. So as soon as you introduce the requirement that the window not only must provide protection against wind, but it also must function and be able to open and close, you start to introduce other materials into the window like gaskets, weather strips, and other seals that have to be able to move, slide, compress, and as a result, water can bypass those gaskets and seals.
So we have a 59 mile an hour water resistant window, and we have 90 mile an hour wind driven rain. What happens?
Well, in a normal rainfall event, like the day in, day out use of a window in the state of Florida, it's not going to be a problem. And the reason is simply that not only do you not get rain or windstorms that typically at 59 miles per hour, but even if you do, the typical rainstorm lasts for a few minutes. You have the wind, it's blowing, and it blows in gusts, but it doesn't go on for a long period. In the event of a hurricane, it's a little bit different story. Having just gone through Irma, I can tell you that we went through it for like 16 hours. Now, granted, during that whole time, that the wind wasn't blowing for 97 miles an hour here in West Palm Beach for 16 hours, but we certainly got a good constant pressure blowing through that rainstorm. What happens is the water starts to build up in the track of your sliding door or your window, and then all of a sudden you get a gust that's added on top of that constant pressure, and that gust speed, which is what you see at the airport in the weather stations, that gust can then push the water and force it to overflow the track. Now, it doesn't mean you're going to have a constant flow of water coming in, but you can have spurting water. Water's going to start to bubble. You're going to see it start to what we call percolate, where it bubbles up around the bottom of the window, and it could even overflow the track. Not a whole lot, but it can happen.
So, and we actually saw that in multiple buildings, probably virtually every building with sliding glass doors up and down the southeast coast of Florida had the phenomenon that you just described. And you said, as you said, not a lot. But what happens to not a lot if it goes on for 16 hours?
Well, again, it depends on how often the wind gusts. If you have an instance where the wind gusts for a minute and it overflows, you're going to get a little water on the inside. And it's like I said, it's not going to be very much. If the wind gusts repeatedly, you can get a fairly significant amount of water on the inside. And when I say significant, I mean enough that if it's not mopped up or cleaned up, it can cause damage to interior finish materials next to the window.
Yeah, so I've often said in these storms, drip can turn into a lot of water over a duration of time. So we talked about duration being a big factor, and I think that's something that's really missed in the analysis. We talk about 16 hours. When windows are tested in the laboratory, how long are they tested for typically?
Yeah, that's obviously is a big difference. You're hitting on a very important point. The standards and codes require that the window manufacturers have to test their windows to these various pressures before they can even, and water resistance, before they can even offer them for sale in the state of Florida. They have to go through these tests. But they also require that the test be a 15-minute duration, not hours like we experienced during a hurricane. So there is obviously a big difference between the hurricane event and the performance requirements that the code mandates for windows and doors.
So these windows and doors, which, many of which in exposed conditions were exposed to factors that were beyond their rating and they leaked, that they were qualified, did meet and continue to meet the requirements of the building code standards. Is that not true?
That's probably correct, yes. They were specified and manufactured in accordance with a set of standards and codes which demand a certain level of performance. But even, for example, we were using numbers earlier where the percentage that is used for determining how much water pressure, we used a number of 9 pounds per square foot. The maximum that's required by the applicable standards is only 12 pounds per square foot. And like we were talking about earlier, when you can convert that into wind speed, and it's nowhere near the 100-mile-per-hour winds that you're going to get, plus the gusting factor on top of that in a hurricane.
So we have Irma came through and caused water leakage through windows and buildings up and down the coast. Does this permanently damage? We're talking about here like the newer hurricane, we call hurricane windows, or the windows that meet the new hurricane codes, which have been in effect for the last 20 years or so. The water leakage event in a hurricane, does that permanently damage the window or door?
No, and that's an important factor that you brought up. Understand this, that the damage that occurs or could occur to the surrounding finishes on the inside, if you got paint stains and drywall stains and stuff like that on the interior, even that can generally be cleaned up and repaired without a major problem. The door itself, in all probability, or the window itself, is in all probability has not been damaged beyond repair. It's pretty rare that such an event occurs, and in fact, for it to occur, normally the storm has to exceed even the wind pressure capabilities of the products. And like we were talking about earlier, that can be 150 miles per hour. So it's doubtful that the window or door itself has been permanently damaged, but you need to make sure. You need to check those windows and doors and make sure there's no damage so that they can weather another storm.
Yeah, so basically the water leakage issues that or problems that we saw in Wilma can be considered a one-time event.
Yes.
Until the next one, I guess. One time can happen more than one time, but it wouldn't cause any problems, any ongoing problems with the normal weather patterns in South Florida, which includes severe thunderstorms and some pretty intense weather, just not anything to compare with obviously a hurricane.
That's right. It should not affect that performance of the product like that at all, and you should still be able to get many years of performance out of the product.
So for building owners that have operable windows that are the newer design, the impact rated and all that, what can they do now or in advance of the next storm to lessen the amount of infiltration?
Well, a couple of things. First of all, you need to go back and look at the windows and doors and make sure that they've weathered the storm okay. There's going to be, like we talked about, gaskets, weather strips, seals, things such as that, and just a simple inspection can be done to check and make sure those accessory materials, which are very important for resistance of water, make sure they're in good shape and they're performing their intended function. Make sure that the window hardware is operating properly, that the locks are able to close and seal the window tight and shut, that you don't have slop and that, like in the case of a sliding door, when the door is in a closed position, it should not be able to move and slide back and forth slightly. It should fit tightly. Everything should be tightly fitted. So check those things to make sure they're working properly, and then check around the outside, around the perimeter of the door and window to make sure that the frame of the window and door is properly sealed to the surrounding wall finish material, whether that be stucco or siding or anything else. So you need to make sure that no water can get in around the window. We've been talking about water getting through, but water can also come in around it if it's not properly sealed. So in general, it's just a matter of checking all those accessory materials in the windows and making sure they're all be able to serve their intended function.
Because, the one thing I was thinking about when you were saying that is that there is a lot of movement during the storm with windows and doors. They're designed to bend in and out with the wind. And in a hurricane, you have cyclic wind gusts. So you talk about perimeter sealant. Well, if there's some movement of the perimeter sealant bead and it's got some age to it, it can actually split open and form an opening that could cause water intrusion going forward, along with just general, over time maintenance requirements, as you were saying, with all the different weather stripping sealants, things like that.
Yeah, it's really important too for the listener to understand that a window that goes into your home, let's say you had it put in, 10 years ago or so, I think it's reasonable for a homeowner to have an expectation that the windows are going to perform for a fairly good period of time. It should last for many, many years. However, the one thing you just talked about, was the sealant. Most sealant that goes around the window that keeps water from coming in around the outside perimeter of the window is susceptible to ultraviolet degradation and drying out and so forth. And so it's not all unusual to see the sealant around the perimeter of the window where just start to crack and fade and deteriorate within 5 or 8 years. So while the window may perform as intended, you could have a lot of water come in around the perimeter because of these sealant failures. So it needs to be checked.
Just needs like a car needs a tune-up every now and then. Operable windows and doors probably need the same kind of attention.
Yeah, it's a good analogy. That's right. You need to look at them. No product that goes into your home is indestructible, and especially if it's got moving components like a window. If it's got something in it that moves, that means it can wear out. So you need to check it.
So the buildings that were leaking in Irma, much of the leakage, I think, is attributed to the intensity and duration of the storm exceeding the rating of the products. But it's also possible that there could be some construction or maintenance issues that would cause or exacerbate leak issues. How can one tell the difference between a one-time event versus a construction or maintenance problem?
Like we were just talking about with the sealant, water leakage can occur through a window because for example, if you have a sealant failure. But one thing to remember is if the water enters around the perimeter of the window because of the sealant failure, it doesn't necessarily happen only in a hurricane. It's probably been going on for a long period of time. And an investigation can determine whether or not the leakage that you experienced was a one-time event or if it's been going on for a period of time. And you can generally tell that by damage and deterioration of materials around the window or door. That gives you a history, if you will, that it makes it clear that if you got, for example, damaged wood trim or damaged drywall, it may be a one-time event, but it's doubtful. It's probably been going on for a while, particularly if the damage is concealed underneath the drywall and it's back inside the wall. That's probably a good indicator that these problems have been going on for a while. So There's other things that also can affect the water resistance capability of a window or door, but these things need to be checked out because a one-time event like a hurricane can overtax the capacity of the window or door, but if you've had water leakage before, it might be concealed, and you need to find out whether there's other damages inside the building or inside the walls that needs to be repaired because it's been going on for some time.
Yeah, the hurricane is like the extreme water test is one way I would say, one way to look at it. So you and I did our first podcast we did together, which was episode 7 in September of 2016. We talked a lot about field water infiltration testing. So that, I think, may be part of how you investigate water leakage. So just how would you go about investigating and repairing water intrusion problems?
Well, the first thing you got to do is identify whether or not there really is a problem. You need to look for the evidence of damage. You don't just want to just go out and start doing water testing. The very purpose of the water testing should be to recreate water leakage events that have occurred. So you need to determine whether or not there's any kind of water leakage that has occurred and whether there's any damage. Then you need to consider the development of a water testing program, the objective of which should be to recreate water leakage that has caused damage. For example, let's say a typical homeowner starts to notice that the baseboard below their window is starting to warp or starting to stain. Well, there's no damage around the window itself, but you know you got something going on because the baseboard is starting to buckle and stain and get this damage. So what needs to be done is the investigator needs to go in there, maybe remove some of that baseboard, start to do some other invasive things and see how far, what the water path is. So, for example, on the inside of the wall, where's the water appearing that's causing this damage? Then do a test and recreate that water leakage path in order to determine what the point of entry is on the exterior of the building. Then from determining where the water entry point is and the leakage path that allows the water to get from outside the building to the inside of the building, which then created the damage, by finding that disconnect from the outside to the inside of the building, you're able to determine what the material is on the outside or on the inside of the wall that needs to be repaired in order to stop that water intrusion from happening anymore. So it's a rather intensive procedure. It can be rather intensive, but the objective is to find the leak, then recreate the leak and track it back to the source so you can eliminate the cause.
So you wrote an article a few years back, didn't you, about this very thing we've been talking about today?
Yes, I did. This goes back, I think, a few years ago, called Hurricane Windows, Fact or Fiction.
So this isn't a new topic necessarily. I mean, it's the awareness level obviously is very high, but that article really did a nice job of covering the whole issue around what is a hurricane window and what can be expected.
Yes, it really discussed all the points that we talked about today.
So that article is available on the GCIconsultants.com website. We've got a blog, and there's actually a lot of articles there that would be of interest on the hurricane topic. But to make it easy for the listeners, if you would like a copy of Will's article, all you need to do is text the word building envelope, all one word, building envelope, to 22828. So again, if you'd like a copy of Will's article, text the word building envelope to 22828. So Will, this has been great. It's really a relevant topic. I know the interest level is probably as high as it'll ever be. And it's really, people are asking all these questions. So I really thank you for providing some real good answers. As always, it's great to have you on.
Great to be here again. Thank you, Paul.
One other thing I just thought of, I just recorded a video last week kind of going over this issue too, where we actually showed some footage where we did some testing to reenact what these leaks look like. So that's on YouTube. So if you go to YouTube and you look for the GCI Consultants channel, you'll find that. And the title is, shame on me, I don't remember the exact words, but something like Water Leakage in Hurricane Irma. So there's another resource. And with that, I'd like to thank everybody for listening again to the Everything Building Envelope podcast. Please tell your friends about it. You can subscribe to it on iTunes or Stitcher. And until next time, this is Paul Beer saying so long.
Thanks for joining us today. Please subscribe to this podcast on iTunes or Stitcher. For more information on the Everything Building Envelope, previous episodes, show notes, bonus video content, and much more, check out our website, everythingbuildingenvelope.com.